Biometrics is already part of our lives. We use it to unlock our phones, open bank accounts, or enter football stadiums. But do you really know how it works? Originally, biometric technologies were designed to share information among authorities, for example, by standardizing passports and ID documents. They worked with biometric templates that represented the physical features of a person's face. In this simplified example, we see how the biometric template describes 3 traits of these individuals. But what risks did this technological solution pose? Each person was linked to a single biometric template, like a key that only fits one specific lock. If that key was stolen, there was no way to revoke or replace the lock. That meant your identity could be permanently exposed. In fact, traditional biometric templates had 3 major flaws. First, reversibility. Since they contained explicit information about facial features, it was possible to reconstruct the original image. Second, uniqueness. There was only one template per person, with no way to replace it if it was compromised. Third, interoperability. They were designed to work across different systems, making it easier for an attacker to use the same template on multiple services. Thanks to artificial intelligence, modern biometrics is now based on what are known as Renewable Biometric References, or RBRs. RBRs are abstract and relative representations of a person's biometric traits that do not directly store those traits. If we revisit the previous example, the traits are now represented in relation to the database. Just like our brain recognizes a face by focusing on what makes it stand out from those we already know, artificial intelligence compares a person's traits to those already in the training dataset. In other words, instead of storing the exact color of your eyes, RBRs classify them, for example, as lighter or darker. The same applies to size, shape, or the distance between features. And without knowing the full system, its programming, rules, or how many people are enrolled, it's impossible to reconstruct the original face. Moreover, every time someone new is added to the database, the RBRs change again, because they are relative by design and can adjust according to the entire dataset. RBRs bring revolutionary benefits to identity management. First, multiplicity. From one face, infinite different RBRs can be generated. Second, your face cannot be reconstructed from them, as because they don't store specific biometric data. Third, non-interoperability. Each RBR works for one specific use case, and if compromised, a new one can be generated. Thanks to RBRs, we've overcome the major risks associated with the widespread use of traditional biometric templates, which were originally designed for information sharing, not privacy. Today, we can confidently say that RBR-based systems are private and secure, by design and by default.